So the manufacturer's instructions said dissolve 28 grams in 1,000 mils of distilled water. This is the manufacturer's instruction for this nutrient agar. But I want to keep at the back of your mind the formula for to prepare cultural media or any other reagent in the lab. We are RV over O. RV over O. I'll tell you how they got to this. Just keep this formula in mind. Now, I want to prepare 500 mils. I don't want 1,000. 1,000 mils is too much. Let's assume I want to prepare 500 mils of nutrient agar now. I don't want 1,000. The question is, how many grams of nutrient agar powder do I need? So, how many grams of nutrient agar do I need to prepare 500 mils? All I have to do is cross multiply and make this x the subject of the formula. So 28 divided by times 500. 28 times 500 over 1,000. Now your R, this is your R. Your R is called required concentration. So R is required concentration. V is required volume, and this is O, original volume. So just in case you forget what R is, what V is, what O is, you can go through this pathway to arrive at the formula. So therefore, R is required concentration, V is required volume, O is original volume. So our R is 28 grams, our V is 500 mils, our O is 1,000 mils. You know the mils here will cancel these mils. So now, if we cancel out, 5 go into 10, 2. 2 go into 28 is 14. Therefore, our answer is 14 grams. You see how simple it is. So what I need to prepare 500 mils of nutrient agar is 14 grams of the agar powder to 500 mils of distilled water. So with that in mind, we'll go ahead. Now, that is the calculation. So I already said I have my weighing balance. What you should do is to always zero your weighing balance. You see that, let's assume you bring the weighing balance, see? And then you place your filter paper. It's going to pick the weight of the filter paper, which we don't want. We're not weighing the filter paper. We want to weigh the agar powder. So the right thing to do is once you put the filter paper on top of the weighing balance, you zero it. You zero the weight of the filter paper so it doesn't weigh the filter paper. See, it's at 0. We've zeroed it. Then we're going to weigh 14 grams. Now, because our agar powder is hygroscopic, that is, if left standing, it's going to pick the moisture from the room and become molten. So we don't want to leave it open for a long time. So we'll quickly pick 14 grams, but we'll add a gram or two in addition to balance the agar powder that will stick to our filter paper at the end. So we're going to add a gram or two in addition, so we'll weigh 15 or 16 to balance the agar powder that is going to stick to the filter paper. Okay, we've weighed more than. So we've picked almost 16. We've already rinsed our conical flask. Remember that this must be done aseptically in the most sterile of all conditions. So you see, there are agar powder that stick to the filter paper. That's the reason for the additional 2 grams. So to balance for this. Now, we've already weighed 500 mils of distilled water. Now, how do you weigh 500 mils of distilled water? You use your lower meniscus to check. Not some people will be checking like this. You don't check like this. You check to know if it's on 500 mils using your lower meniscus. So it's on 500 mils now. So we add a little portion of this to get a homogeneous mixture first. You don't add everything, so you mix properly. So mix with a little quantity of distilled water to make sure that the agar powder is mixed with the distilled water. Then we add the remaining distilled water left. So now you see, we are ready to autoclave. So we are now at this is our autoclave. This is our autoclave. This is the lid of the autoclave. Now the autoclave has a valve. This is the valve of the autoclave. This is the temperature and the pressure gauge. Now this is the basket of the autoclave. The basket of the autoclave. Now it has a heating ring inside with water. Water must cover the heating elements. So before every autoclaving, you check if the water is covering the heating element. So we already added water to the heating element. So now we'll put the conical flask containing our agar inside the autoclave basket. Place it like this. And then you cover with the lid. Now to seal, we seal at opposite directions. That is to seal like, first off, put the knot. So these are instruments of sterilization. Now the autoclave uses moist heat sterilization. So you see I'm sealing at opposite directions like this. It uses moist heat sterilization. At increased pressure, the temperature of water goes beyond 100 degrees Celsius to give you steam that will penetrate into your items that you want to sterilize or autoclave. So it uses moist heat sterilization. So now, as one autoclave, we're going to leave the valve open so that whatever air that is present, that is trapped inside the autoclave will go out before we cover it for the temperature, the pressure to build. If we close it like this at the beginning of autoclaving, the pressure will not build, because for the temperature of water to go above 100 degrees, it needs the pressure to go above the atmospheric pressure as well. So we need the pressure to be at 15 psi for the temperature to rise up to 121 degrees Celsius to produce things that will penetrate the elements for sterilization to cause coagulation of bacterial proteins that kill the bacterial organisms or any organism if present, because we want to produce a sterile culture media. I told you earlier that these things are done in aseptic procedure. So whatever organism is there that is there in our medium, by any chance, we want to kill all of them, because we don't want to see growth and think that it's from our patient when actually it's from our culture media. So we have to sterilize it. So now you put it on. You see our autoclave is on. So what happens is when the water boils, it rises up to 105, and then that's when you close the valve. So now the valve has to be opened. It has to be opened. So sterilization begins at the first whistling sound. So once you hear the first whistling sound, you know that the temperature is up to 121 degrees Celsius. That is called sterilization time. It lasts for 15 minutes, after which you put off the autoclave and then you allow it to cool before you open the autoclave. Note, do not open the autoclave when the temperature is still high or when the pressure is still high. You have to allow everything to cool back to zero before you open the valve, and then you open the nut and bring out your item. So our media is all is ready. We finished autoclaving and we've sterilized our bench. We sterilized our bench with spirit and cotton wool, and we've plated out. Now the base of the Petri dish is meant to be down while the lid up. That is how you plate out. The base should be down while the lid up, to avoid pouring the media into the lid. So the base should be down while the lid up. Now we have to pour for our nutrient agar. So as we pour, we mix to make sure that our agar is not at the base. Standardly, we don't talk while pouring, when preparing our media, but for learning purposes, as we pour, we have to mix. For learning purposes, I'll have to be giving the instructions. So you pour about 20 to 25 mils of molten agar into each Petri dish. About the middle of the Petri dish should be about 20 to 25 mils. So you just pour the molten agar halfway into the Petri dish. So now we are done. Now next is prepared our blood agar. Now we have to allow our media to cool to cheek temperature to avoid lysing the blood, since it's blood agar preparing, not chocolate agar. Now our molten agar is cool. The next thing is to prepare 10% blood agar. 10% blood agar, that's what we are preparing. Now remember that we prepared 500 mils of molten agar and we poured 250 mils to make nutrient agar. So now we have 250 mils of molten agar left. Now, to prepare 10% blood agar, you will use the formula RV/O, where 10 mils of blood will give you, is poured into 100 mils of molten agar just from the percent written there. The 100 stands for the percent. So 10 mils go into 100 mils of molten agar, 10 mils of blood. So how many mils of blood we need to pour into 250 mils of molten agar to give us 10% blood? So cross multiply. When we cross multiply, saying we have 10 times 250 mils of molten agar over 100 mils, where 10 is a required concentration, 250 mils is the required volume, and 100 is the original volume. So 10 is required concentration, 250 mils is the required volume. That's the 250 mils we have in our conical flask, while the original volume is 100. So we'll cancel out. So what we have left is 25 mils of blood. That is our answer. So we need 25 mils of blood to prepare 250 mils of blood agar. So we have our 25 mils of blood here. So we're going to pour it into our 250 mils of molten agar sterilely. Now mix very well. So this is our blood agar. So this is how it should look. This is our blood agar. Now pour about 20 to 25 mils into each petri dish. So now we have poured our blood agar, and then we have our nutrient agar. So now we are going to allow both to gel. Media is gelled. Now once the media, we poured our plates like this. So once it's gelled, you invert the plates so that the droplets are on the lid of the plates. This is how you store, with the base above and the lid below. So the next thing is to label the plates. So I'll label this NA, that's nutrient agar. So now, after labeling, you refrigerate at 4 degrees Celsius. You stack these and you refrigerate at 4 degrees Celsius in your refrigerator. So we'll also do the same thing to our blood agar. So for blood agar, we invert and write BA, that's blood agar. You write it at just one part of the plate so that you don't take up the space for patient's detail and name. BA. So we invert, and then we'll store at 4 degrees Celsius in the refrigerator. We'll stack them and store. So basically, this is how you prepare your culture media. So this is your enriched media, your blood agar, and this is a basal media, your nutrient agar. I hope you've learned something in this video, and if you've watched this video to this point, I would encourage you to subscribe, to like, to share this video for more educative content. Thank you.